Okay, good morning, everyone. Okay. Before we get started on last chapter 8, do you have any questions? So we're going to talk about the chapter 8, hypothesis testing. Okay. So, and it's fall under the inferential statistics, chapter 8, hypothesis testing. It's one major topic in the inferential statistics. So basically, we are testing hypothesis, right? Hypothesis. Let me just lay out the foundation for the hypothesis testing. First of all, is hypothesis. So basically, it's a claim or statement about a population parameter. Claim. Statement about the population parameter. And then hypothesis testing is a standard procedure of hypothesis test. And basically, it's a standard procedure for testing a claim about a population parameter. So basically, we just follow the procedure. We should be able to do the hypothesis testing. For testing claim about the population parameter. So those two are very important concepts in terms of hypothesis testing. And next, let's talk about the procedure of conducting a hypothesis testing. So we have a 4-step procedure. Okay, the standard procedure. So step 1, we state no in our alternate hypothesis. So we have 2 hypotheses. One of them is called null hypothesis. The other one is called alternative. And null hypothesis, we're using HO. Use HO to represent null hypothesis. And we're basically just testing whether or not null hypothesis is true, right? So testing the validity of the null hypothesis, right? And also a second hypothesis called alternative hypothesis. Okay. And so we call this H1 or HA, right? Depends on different textbook or PowerPoint. They use different symbol, but yeah, H1 is to do the work. And H1 usually is the opposite, either the opposite of HO, or another way you can say that it's a complement of HO. Either one of that. Okay. So this is step number 1. Stating no and alternate hypothesis. Then usually either one of these will be given in the problem. Or if you work for a company, usually your direct supervisor will tell you, what you try to test. And that shouldn't be an issue. You'll be able to find that. Second step is calculating the test statistics. Calculate the test statistics. Typically it's a z-score, right? So we calculate z-score using one of the formula. I'm going to show you in a second. Or maybe let me show you what the z-score, where you get that from. Okay, so you go to the formula sheet. Let's open the formula sheet really quickly. And we go down to chapter 8 formulas. Should be on the second page. It's right here, right? So basically we are using those three formulas and mostly concentrating on the z-score here. So x bar minus mu over sigma over square root n. And we also call this central limit theorem, right? This is the formula for the central limit theorem. And also we have t-score. I'm going to talk about t-distribution in a second. When sigma is unknown, then we're using t-score. Sigma is known, we're using z-score. Okay, so that's the difference between this for one population. We're also testing the proportion, but we're not going to focus on this too much for this chapter. We're going to mainly focus on testing for the mean because it's more widely used. Okay, and basically focus on those two formulas, right? And to calculate z-score. Okay. Now let's go back. So calculate the test z-score, right? Using either one of those formula. The step 3, third step, based on alpha. And alpha basically is the complement of confidence level, right? If confidence level is 90%, then alpha is 10%. That indicates alpha is 10%. So alpha is a complement of confidence level. That's also given or predetermined, right? If it's 95% confidence level, then alpha is 5%. So based on alpha, you determine the rejection region and non-rejection region. Rejection region basically tells us reject HO, right? Reject null hypothesis, and then non-rejection region. So in the non-rejection region, we fail to reject HO, or we do not reject HO. So basically, you draw the bell curve, right? And based on alpha, we'll be able to find out the critical z-score, right? And if this is a rejection region, right? On both tails here, it will be rejection region. So this is what we call rejection region. Rejection region. And in the center area is non-rejection region. So if the test statistics z-score, right? If let's say the z-score fall in the rejection region, fall in here, then reject HO. But if it is fall in the non-rejection region, then we fail to reject or do not reject HO. So that's a basic structure. We're still using the bell curve. This alpha determines critical z-score. And based on critical z-score, and then we determine the rejection region, non-rejection region, then compare the z-score, test statistics z-score, to the critical z-score and determine whether to reject HO or fail to reject HO. So that's the third step. And the fourth step is determine, come up with the final conclusion, reject or fail to reject the null hypothesis, HO. Okay, so that's basically the general procedure. So you just follow these 4 steps and we'll be able to get down to the bottom of this hypothesis testing. And do you have any questions about this procedure? So, no question. So let's talk about student t-distribution. Okay. So when sigma is unknown, meaning there's no way to find out the population standard deviation, and you have to use a student t-distribution. That's where that t-score formula comes from, right? You see from the formula, t equal to x bar minus mu over sample standard deviation over square root of sample size. That's where this formula kicks in when the sigma is unknown. So in order to use student t-distribution, there's two requirements. First one is the sample is a simple random sample. We'll talk about this in chapter 1. It's a simple random sample. A guarantee is randomness of the sample. And the second thing is either the sample is from a normally distributed population. 99.99% of the time, that's the case, right? Because when we're talking about population, it's usually large population, and that always follow the normal distribution. So most of the time, this statement is always true, right? The sample is always coming from the normal distributed population. Or either this is true or sample size is greater than 30. So now once these two are satisfied, then we can apply the student t-distribution. And let me just explain the student t-distribution really quickly. Let's draw a bell curve. So this is normal distribution, okay? And student t-distribution looks very similar to a normal distribution. Let me just go use a different color so you can distinguish them. Basically, it's very similar to the normal distribution. The only difference is just it still looks similar to the bell curve, but it just looks slightly different, right? So according to this, we have following statements describing the student t-distribution. So the green one represents t-distribution, and then the red one represents normal distribution. And as the sample size gets bigger, meaning as sample size n gets bigger, then the student t-distribution gets closer to normal distribution. Gets larger. Then t-distribution gets closer to normal distribution. That's the first statement about student t-distribution. The second thing is the different sample size, right? The curve for t-distribution will be different. So the curve for t-distribution is different for different sample size. That's the second thing about the student t-distribution. Also, the student t-distribution has following statement. The t-distribution has a mean, so the mean is t equals 0. And the standard deviation of this student t-distribution is greater than 1. So the standard deviation is greater than 1. Okay, so it's not 1 anymore, right? For the standard normal curve, standard normal distribution, we know that Z-score equal to 0, right? And then also standard deviation equal to 1. Right in the center, right? Standard deviation equal to 1, also the sample mean. Zero, right? So that's true about standard normal distribution. But for the student t-distribution, then t-score is 0 in the center, right? Right in the center here. Here, this for the bell curve, for the normal distribution, z equals 0. And then for the t-distribution, t equals 0. But the standard deviation is slightly different. That's why the curve varies a little bit. And then, yeah, so that's basically pretty much everything. It's also symmetrical, right? So it's symmetrical with respect to center. Symmetrical with respect to the center. Which is t equals 0. And it's in the center, t equals 0. So it's like bell curve. And as the sample size gets close, gets bigger and bigger in terms of the student t-distribution, then this one gets closer and closer to normal distribution. And that's basically what distinguish student t-distribution from a normal distribution. But they are very, very similar, right? So in the total area under the curve is also 1, just like normal distribution. Okay. And do we have any question about the t-distribution? Okay, so basically for t-distribution, as I mentioned earlier, we are using this formula, t-score equal to sample mean minus population mean over sample standard deviation over square root of sample size. And here, we need one thing is called degree of freedom. In order to look up the critical t-score, okay. So degree of freedom, basically it's equal to sample size minus 1, okay. And also we need alpha, right? So two things to determine the critical t-score. Alpha is same thing as saying confidence level. So if we know the confidence level and degree of freedom, we'll be able to find out the critical t-score. Okay, and I'm also going to show you the table where you go by, right? So use the table A3 here, basically. So it's not A2, it's A3. It's the table underneath the table A2. But it works slightly different from the table A2. And this table, we need two things, right? Area in two tails, meaning alpha, right? Area in one tail, this is what they go by alpha. So use alpha on the top column here, and degree of freedom on the very left column. So come up with the degree of freedom, and based on confidence level, we know alpha, or sometimes alpha is given directly. You can use that. Then you're going to come up with the intercept. For example, let's say degree of freedom equal to 9, and then alpha equal to area in two tails equal to 0.05, right? 95% confidence. That means area in two tail is 0.05. Then the intercept is 2.262. So this is what we call the critical t-score, right? Critical t-score or critical t-values. And we find that from this table A3. And I'm going to explain this in detail once we get to the example. Okay, I'm going to go over a couple of examples in a bit, just help you understand how to apply the procedure also in terms of calculation. But do you have any question about what we talked about so far? All right, very good. So now let's take a look at a couple examples. Okay, let's start with this, right? I posted a file in Blackboard. So if you log on to the Blackboard, and you could open this, it's under the syllabus and formula sheet. If you open that, I post this hypothesis testing example, spring 2021. And you can open that file, right? I should be able to see this example, both examples here. So we're going to apply the hypothesis testing procedures to show you the details. So let's look at it together. All right, not print screen. Paste into the note.
I'm sorry, where do I find that again?
Okay, one more time. It's go to Blackboard. The formula syllabus and formula sheet. Okay, and then the very last file, right? You see examples.
Thank you.
All right. So open the file. Let's look at example 1 first. And this is about example 1 is about z-test, right? So using z-score to determine the outcome of the hypothesis testing. And let's go through that step by step. Okay. So now let's look at this. First of all, let's analyze what we have so far in the question. Okay. All right, so insurance company, right? So basically reviewing the current policy rates. Okay. And when originally setting the rate, they believe the average claim amount will be $1,800. Okay, so this average claim amount, right? Anytime you see average, means it's kind of mean, right? So we're talking about mean, but what kind of mean is this? Is it population mean or sample mean? Any idea? Is this the average claim amount for all claims, or just an average claim amount for certain claims? It should be the other one, right? All claims, because when they set up the policy rate, they basically will look at all the claims and maybe just add up all those claims and divide by the population size. So this is actually the population mean mu. Okay, so we're given the population mean mu $1,800. Okay. And they are concerned that the true mean is actually higher than this. Okay, so this is their concern. So this one, if you look at it, higher than this, meaning true mean, so they want to test this. This one indicates mu is greater than $1,800. Okay, if this is the case, then the insurance company could potentially lose a lot of money. If this happens, then basically the company is in a very bad position. So they may lose a lot of money, right? So you want to avoid this happening. So they randomly select 40 claims. Okay, so now randomly select indicates this is a simple random sample, right? And 40 claims is what we call the sample size, 40. Okay. And the calculated sample mean, very specific term, right? Sample mean. And based on this, we will know that the other one must be population mean. You cannot have two sample means in a given problem. Okay. So the sample mean X bar here is 1950. Okay. Assuming the standard deviation of all claims is $500, here, this 500 indicates population standard deviation is 500. Okay. And also alpha is given. Okay. That means alpha is 0.05. That indicates they want 95% confidence. So the confidence level is 95%. So going vice versa, right? If you know the confidence level, you know alpha because they are complement. Okay. So test to see if the insurance company should be concerned. Okay. So first of all, I probably forget to mention one thing is the null hypothesis always need to have an equal sign. Must always have equal sign. Keep that in mind. Very crucial, right? Very crucial to determine the null and alternate hypothesis. And right here, since higher than this one cannot be null hypothesis. So actually this one becomes alternative hypothesis. So the question is basically given the alternative hypothesis. Okay. So now we basically can utilize this piece of information to determine the step one, right? So we state the null and the hypothesis, alternative hypothesis, state the null and alternative hypothesis. So the null hypothesis HO, alternate hypothesis H1. Okay, so since we know this has to be alternative hypothesis because there's no equal sign here, just higher than this, greater than 1800. So that has to be the alternative hypothesis. Mu is greater than 1800. Then your null hypothesis could be the complement, right, or opposite. So the null hypothesis will be mu is less equal to $1,800. Make sure to have equal sign here. It has to be an equal sign. Another way of setting null hypothesis is mu equal to 1,800. So here you do have an option, either set up as that or mu equal to 1,800. But just make sure your null hypothesis has equal sign. Equal sign. An alternative hypothesis has no equal sign. So basically, we determine the null and the alternative hypothesis. And you do have an option to set up the null hypothesis either less equal to 1,800 or equal to 1,800. And think about this. If it is less equal to 1,800, then the company is fine. They will not lose any money, right? If equal to 1,800, they still will not lose any money. So they're good. They're in a good financial position. So that's basically what we look at first. Second step is determining the test statistics, ZScore. Okay, so step 2, calculate test statistics, ZScore. So we're using the ZScore formula. Basically, it's a central limit theorem. So Z-score equal to sample mean minus population mean mu divided by population standard deviation over square root of sample size. Okay. Based on the analysis from the question, we have all the numbers, right? That's why we need to analyze the information first, get all these important elements, then we go from there. So population mean is 1,800. Sample mean is 1950, sample size 40, sample standard, population standard deviation is 500. So all 4 pieces of information are listed in the question. So just have to list it one more time. Mu is 1,800, sample mean is 1950, sample size is 40, and population standard deviation is 500. Okay. Again, we get it from the question. Okay, now throw into the formula. So we have 1950 sample mean minus population mean 1800 dividing by population standard deviation 500 divided by square root of sample size. Okay, let me show you how to do this in Excel really quickly. And make sure you put in the proper parentheses for this. It's very important. A lot of students make mistake when I teach the course in terms of calculating the z-score here. I want to make sure you do not make that mistake. Okay. So first of all, let's put a numerator in the parentheses. So it's 1950 minus 1800. Okay, that goes in the parentheses. I also put a denominator in the parentheses. So standard deviation 500 divided by square root of 40. Okay. This is the proper input. Then once you hit enter, you get a result. And remember, for all the z-scores, we run it to 2 decimal place. Okay, so let's trim down to 2, right? 1.90. So the z-score is 1.90. Test that this z-score, right? Approximately. Okay. Now, based on alpha, so this is second step. It's basically applying the formula, get a test statistics, right? Now, step 3, it's based on alpha, determine the rejection region. Now we know alpha is 0.05. That's also given in the question, meaning we have 95% confidence. So when alpha is 0.05, and if you look at it, this is what we call the right tail. So now this is another important aspect here is based on the alternative hypothesis, we determine whether we have 3 scenarios, right tail, second scenario, left tail, or 2 tails. Third scenario, 2 tails. On both left tail and the right tail. And if it's greater than, if the sign in the alternate hypothesis is greater than, that means it's right tail, right? If this is greater than right tail. If it's less than, then it's left tail. If it's not equal to, then it's 2 tail, right? So this determines what kind of test we're looking at. So this basically is what we call a right tail test based on the alternate hypothesis. So now hypothesis must have equal sign. Alternative hypothesis determines which tail test we are conducting here. Okay, so now we know that this is right tail test. Why this is important, I'm going to show you in a second. So now we're going to determine the rejection region, non-rejection region, right? Since it's right tail, you draw the bell curve. Now right tail is right here, so critical z-score we're looking at the alpha, right? It's right here. So meaning this is right tail here, and this is what we call a rejection region. So the right tail is the rejection region. That means area to the left is the non-rejection region. So alpha helps us, and then the right tail test help us determine the rejection region, non-rejection region. And how do we utilize alpha? So if alpha on the right tail is, this area is 0.05, that means area to the left is 0.95. Okay. And based on that, we'll be able to determine this critical z-score here. Okay, so again, we go to table A2, z table. So go to the formula sheet first. Okay, open the formula sheet. And since it's z-test, so we go to z table. and look for 0.95 in the center, right here. In the center area, we look up the critical Z-score here. So 0.95 is right in the middle of 0.9495 and 0.9505. So if you follow direction arrow, go down all the way to the bottom, you will see that the Z-score is 1.645. Okay. So that being said, so we find a critical Z-score here. So go back here. So that means this is 1.645. Okay. So this is the critical Z-score, right? Separating the non-rejection region from rejection region. Now we look at test statistics score, right? So 1.90 actually it's falling into the rejection region. It's on the right tail. So the test statistics is right here. Test statistics Z-score is 1.90, bigger than 1.645. So it falls into the rejection region. So the step 4 is the final conclusion. So since the test statistics Z-score Z-score equal to 1.90, falls into the rejection region, then we reject HO. Then we reject HO. Meaning HO is not true, right? Rejecting HO is saying HO is not true. That's like essence behind what this reject or failed to reject mean. When we reject it, meaning it's not a true claim. That's why we reject it. Okay. So since we reject HO, the indication is alternative hypothesis, it will be true, right? It's true. So the true mean is actually higher than $1,800. The consequences of that is the company will potentially lose a lot of money. So the management is looking to this, the rate of claim and probably modify that, right? So the actual implication is the actual mean. All right, so this is something, to guide the management. The actual mean is higher than $1,800. And if that happens, then the company potentially a lot of money. So they should look into that and modify the claim amount, right, of the policy rate, right? They should modify the policy rate to avoid this. So again, hypothesis testing is just a tool to guide a lot of operations or business decisions. So it's heavily used in the business field, and a lot of companies actually they hire statisticians, run analysis, help them determine whether a project is profitable or not profitable, and they will make a decision based on that, or maybe adjust the price, adjust in this case adjust the policy rate, so they could stay in the business. Okay. Any question on this? So a couple important points is null hypothesis must have equal sign. All right, that's one thing, right? Equal sign is needed for the null hypothesis. Second thing is alternative hypothesis determine which tail test we're looking at, right? Either it's right tail, left tail, or two tails. And in a bit, I'm gonna show you two-tail test, which is another question in question number 2. And you will see how this plays out, right, in a second. Okay, but before we wrap up the question, any concern about the procedure or any specific point you want me to explain? I'm more than happy to do that. Okay, then let's look at the question number 2. All right, so very similar. It's about grocery store, right? So now let me print the screen. Okay, and this one we're going to use t-test, and I'm going to show you why we are using t-test for the question number 2. Okay. First of all, let's run through the question. Let's take a look at what's given here, right? So the sample, that's very clear indication we have a sample, and this is a sample size, n equal 40. Okay, so that's first piece of information we extract from the question. So we're talking about the sales receipts, right, from this grocery store. I see sample mean, very specific X bar, right? It's given $137. Okay, and the sample standard deviation S equal to 30.2. This being said, meaning sigma is unknown here. If you are given the sample standard deviation, then the population standard deviation is unknown. Then we know that we're going to use t distribution. So the indication is pretty straightforward. You just look for population standard deviation. If it is including the question, then z I mean using the z table, right? I mean normal distribution we're talking about. And if sigma is unknown, if they're giving you the sample standard deviation, then we know that we're going to use t distribution for sure. So use this value to test whether or not mean sales, right? That's not this. Mean sales at a grocery store are different from $150. Different from indicate mu not equal to $150. Different from is not equal to, okay. And this has to be alternative hypothesis because there's no equal sign here. It's not equal to. And that being said, then the null hypothesis must be mu equal to, right, $150. That has to be null hypothesis. Because they are complement or opposite. Okay. Either way you want to put it. Okay. So now we know that it's t distribution, t-test we are using, and also we come up with the null and alternate hypothesis. That's what we get from the analysis of the information of the question. Right. So now next thing, step 1 still follow same procedure. Step 1 state the null and alternate hypothesis. Null hypothesis HO, we know that mu is equal to $150. Okay. And then alternate hypothesis H1 or HA, some textbook using HA, is mu is not equal to $150. And based on this alternative hypothesis, not equal to indicates we're talking about two-tail test. So the rejection region folding both tails, left tail and the right tail. Two-tail test. Both on the left and right tails. Whenever we see that not equal to in the alternative hypothesis. All right, so now that's step 1. Step 2, calculate the test statistics, t-score here, right? And this one is t-test, calculate the test statistics, t-score. So we're using t-score formula. T-score equal to sample mean minus population mean divided by sample standard deviation over square root sample size. And let's list all the information from the question. So we know sample size, we know sample mean, we know sample standard deviation, we know population mean. It's 150. Okay. That's why the null hypothesis must have an equal sign. Because population mean sometimes may not be given in the question. So we are still going to use that. So equal sign will determine that the population mean. We can always locate the population mean. Okay. Now one more time, let's list everything in the question. Sample mean, 137. Population mean mu, you can also find it here. Okay. It's 150. And sample standard deviation is 30.2. And sample size, that's, let me see, 40, I believe. Yeah, 40. Okay, so now we have all the numbers. Throw into the formula, get the t-score. 137 minus 150 divided by 30.2 over square root of 40. And notice that student t-score must be running to 3 decimal place. I'll tell you why in a second. If you go back to table A3, so this is table A2, right beneath it is the table A3. You see all this critical t-score has 3 decimal places. That is why we want to keep it consistent. So the t-score we're calculating must have 3 decimal places. So that's the reason we keep the t-score 3 decimal places. Okay, so and from here, let's calculate the t-score, test statistics t-score. Now go to the Excel and let's input the calculation into the Excel for equal sign 137 minus 150. Okay, I'm dividing by 30.2 divided by square root of 40. Okay, and that's pretty much it, right? So that's proper input. And once you hit enter, you get a result. That will be a negative number. And we want 3 decimal place. Okay, so it's negative 2.722. Okay, and that's the number we're looking for, negative 2.722. Negative 2.722. So this test statistic t-score. Now let's find it, based on alpha, let's find a critical t-score, a t value. Okay, so step 3, based on alpha, which is 0.05, I believe. Well, it's not given here, so that's assuming alpha is 0.5. 3 common values for alpha, right? 0.05, 0.01, 0.10. So that's still using 0.05. Alpha equal 0.05. Then let's find a critical t-score. And we know there's two-tailed test based on the alternative hypothesis. So you draw the similar to bell curve, right? And we know that it's two-tailed. So on each tail, we have a half of alpha. So this is negative, the T alpha over 2. T-score, critical T-score, and T alpha over 2. And we know that on both tails, we have a rejection region. So this is rejection region. This is a rejection region. And the middle one is non-rejection region. The next thing is find out the critical T-score, right, from the table A3. And we know alpha is 0.05, two tails. Degree of freedom is sample size minus 1. Sample size is 40, minus 1, that's 39. So two things, alpha and then degree of freedom, that will give us the critical T-score. And one more time, let's go to table A3. 39, okay, here we go. So degree of freedom, 39, and then area in two tails, the combined area in two tails is 0.05. So that will give us intercept. Intercept is 2.023. Okay, and from the table, you're only going to get the positive one, right? Positive is critical T-score or T-value. Negative one is just opposite because it's symmetrical with respect to center. So this critical T-score is 2.203 on the right tail. 2.023. On the left tail will be the exactly opposite. So the critical T-score on the left tail is negative 2.023. Negative 2.023. And now, just like the other one, we're gonna compare the test statistics, negative 2.722. And negative 2.722 actually is it's smaller than this. So test statistics T-score is negative 2.722. So on the left-hand side of the critical T-score, and this falls into the rejection region. Falls into rejection region. And that builds a foundation for our conclusion. Okay, so the conclusion is, since it's falling in the rejection region, so step 4, we reject HO. That's what this is about. Reject HO, meaning HO is not true. It's like a rational behind it. So what this tells us is, if this is not true, then that means alternative hypothesis is true. So the average sales, the mean sales at the grocery store are different from $150. Okay. So the conclusion here is the mean sales at this grocery store is different from $150. And that's what we get out of this hypothesis testing. So the store manager maybe will look into that. And if they want to, so since it's different from $150, they have to come up with a better estimate, right? See what is a better estimate. They need to look into that. So they could improve on the estimate. So again, this is business related, and we utilize this procedure to come up with the evidence to either reject or fail to reject HO. And this question doesn't have I guess I will, let me see. I think I have another example I can show you guys about this hypothesis testing. But think about this. This one is we're using t-test. meaning we're using table A3 to determine the outcome. I guess I will provide a question that I will put into this. Give me 1 second. Then I want you guys to try this one yourself and to see if you understand the concept. And I will go over this in a bit. And let me just first of all upload this file really quickly. Okay. But yeah, think through this procedure, right? And it's quite useful for you to understand this about this testing. And add another question in that sheet. Just you can look at it yourself. Okay. So I'm uploading the file right now, so you can reopen the file I just attached, and I add a question in the back, so you can look at that question yourself. All right, so one more time, let's go to the level. I want you to open the file one more time. I just modify that. I add another question in this file. Let's open it. And there's a question number 3 here. I want you to look at it yourself. Now you look at question 3, and so basically it's about the school scenarios. Suppose you have a sample of 11 economics 70 midterm exam grades. The mean of that sample is 81 with a standard deviation of 9, right? So here you are given a sample standard deviation 9. First one, test hypothesis, the average grade for the population is 75 with 5% significance level. This tells us alpha equal to 0.05. So significance level is the same thing as alpha. Okay. And second one, test hypothesis, the average grade of population is greater than 80 with a 5% significance level. Okay. So you're testing two things. First one is average grade of population is 75. Second one is greater than 80. All right, so try this really quickly. Okay, guys, so let's go over the solution for question 3. Also, I'm going to briefly talk about the p-value method. It's also one method in talk about in PowerPoint. And it's very similar to what we did, right? In terms of rejection, non-rejection method. And then rejection, non-rejection method works for both z-test and t-test. The only thing about that p-value method, it only works for the z-test. Okay, that's why I didn't focus on the p-value method at the very beginning. But yeah, let's look at this question really quickly. And you can take a look at your solution, double check it, make sure you have the right thing. Okay, so now let's look at it. So let's look at part A first. We start with the analysis of the whole thing, right? Start with the analyzing the entire situation, see what's given here. Let's try to make it larger. Okay, here we go. So we know we have a sample here. Okay, that's first thing we know. So we have a sample of 11 grades. So sample size is 11. Okay. The mean of the sample. So sample mean is given. 81 is the sample mean. X bar is 81. Okay. And sample standard deviation is given. S is given 9. Since sigma is unknown, then we're using t-test. Okay, so this is very crucial, right? You want to use the right test and t-test. Applying the t distribution here. That's what we find from the question itself. And part A, test hypothesis, the average grade of the population. So testing mean, population mean equals 75. For any school, right? They have more than 11 economic students, taking the midterm exam. So the population could be like maybe 500 students, and we're picking a sample of 11 students, and with their midterm exam grade. So we know that we're going to test the population mean equals 75. Here, since mu is equal to 75, so this is exactly the null hypothesis we are talking about, because there's an equal sign here. Okay. And we also know alpha, right? Alpha is 0.05. So now let's start with the part A, and let's start with the stating the null and an alternative hypothesis. Null and an alternative. Hypothesis. HO is population mean equals 75. And H1, you can do a two-tail test, meaning mu is not equal to 75. That's okay, right? Nothing wrong with that. But since the sample means 81, so you probably want to move to the other direction, which is the right tail test, because the sample mean is slightly bigger than population mean they try to test. So maybe what you can do is even better do right tail test. U is greater than 75 based on the sample mean. Okay, so we know that this what we go by is right tail test, because the sample mean 81 is slightly bigger than population mean 75. Okay, and that's why we decided to use the right tail test. But if you want to do two tail test, nothing wrong, right? Mu not equal to 75, totally fine. Okay, the step number 2, we're going to calculate the test statistics. Calculate test statistics. So meaning t-score, right? A t-value. So we're using t-score formula. T-score equal to sample mean minus population mean over sample standard deviation over square root of sample size. Sample mean is 81. It's slightly bigger than 75. Population mean is 75. We get it here. And sample standard deviation is 9. Sample size is 11. Okay. All of these you can find it from the question. Now that's plug into the formula. 81 minus 75 over standard deviation, not over square root of 11. Now we're going to use Excel to do the calculation one more time. So 81 minus 75 dividing by open parentheses, 9 over square root of 11. All right, so once we put in the right form, he enter 3 decimal place for t-score. Okay, 2.211. Okay, 2.211. Go back here, it's approximately 2.211. Okay, so that's a test statistic t-score. So get that. And now third step, based on alpha, let's find out the critical t-score. Alpha significance level is 0.05. And we know that it's a right tail test. Okay, so if you draw the identical bell curve, then right tail is right here, right? So this is what we call a rejection region. And T alpha should be here. Okay. So all the significance level concentrated on the right tail, 0.05 here. And this is what we call rejection region. Now let's go back to the degree of freedom really quickly. Degree of freedom equals sample size minus 1, sample size 11, minus 1 is 10. And we know alpha equal 0.05. That's area in one tail, right? In right tail. Now, based on these two pieces of information, now go to table A3. So let's go to the table A3. Degree of freedom is 10. Okay, and the area in one tail, 0.05. Okay, so this is the difference, right? If it's two tail test, you look up here. Area in two tail 0.05. The area in one tail will be 0.025. But if it's one tail, you're going to look up this. If area in one tail is 0.05, the area in two tail will be 0.10. So here the area is on the right tail, so it's 0.05 together with the degree of freedom. So the critical t-score or critical t-value is 1.812. Okay, and 1.812, that's what we're looking for. So critical t-score here is 1.812. Now you look at the test statistics. Since this number is bigger than critical t-score, so the test statistics right here. Again, it falls into the rejection region. Okay, so that will lead us to the conclusion is 2.211. So test statistics fall in rejection region. Falls into the rejection region. So that tells us conclusion is reject HO. Meaning HO is not true. Enough evidence to prove that HO is not true. So that being said, if this is not true, then alternate hypothesis must be true. So the average grade of the population will be greater than 75. So average grade of the population is greater than 75. Okay. So that will provide some, feedbacks for the instructors or maybe for the school, how to improve the quality of the course. They can come up with some, modification, to the course contents or something like that. So this will provide some guidance. And this is part A. And we're also going to take a look at part B. More time. Part B is similar to what we did, right? And all the given information is the same. We're just testing a different thing. Again, sample size is 11. Okay. Then sample mean, 81. Sample standard deviation, 9. Then t distribution, t-test. Because population standard deviation is not given. And Hobby test hypothesis, the average grade of the population mean mu is greater than 80. Since there's no equal sign here, then we know that this must be alternative hypothesis. Alpha is given, alpha is 5%, meaning with 95% confidence. So we know the alternate hypothesis. So the null hypothesis, what we can do is we can do the opposite, right? Mu is equal to 80 or less equal to 80, exactly opposite. So this is null hypothesis. Must have equal sign because we need a population mean in the calculation. So one more time, we're going to state the both hypotheses. Step 1, state the null and alternative hypothesis. So the null hypothesis HO must be mu less equal to 80. Right? Average grade is less equal to 80. 80 being the cutoff score. Right? And the H1, okay, mu is greater than 80. Okay. And based on the alternate hypothesis, we know that this is a right tail test. So it's one tail, right tail test. Now step 2. Let's calculate the test 36. T-score. So T value equal to sample mean minus population mean mu over sample standard deviation over square root of sample size. Sample mean it's 81, given the question. Sample standard deviation, that's also given. Population mean, here we're using 80, mu equal to 80. And that's why the null hypothesis always have equal sign, right? So we know which value we decide to use. Sample mean 81, population mean 80, cutoff score. Sample standard deviation 9, sample size it's 11. All right, so now I'm just throwing out numbers, 81 minus 80 over 9 over square root of 11. Okay, so let's get the t-score or t-value from Excel. Okay, so it's 81 minus 80 divided by standard deviation, open parentheses, 9 over square root 11. Okay. Proper input, enter 3 decimal places. 0.369. So we get that 0.369. Go back here. So we find the test statistics of step 3 based on alpha. And we know it's right tail test. And we'll be able to determine the critical t-score, right? So draw the bell curve. Okay, so right tail test, so rejection region for in the right tail, so T alpha. Okay. And degree of freedom is the same, sample size -1, 11 -1, that's 10. And alpha is 0.05. That's area in right tail, in one tail. Okay. Now one more time, let's go back to the table A2. And 10, degree of freedom 10, and then area in one tail 0.05. And the critical Z-score, critical T-score is 1.812. Okay. So we find the critical T-score 1.812. All right. So this is rejection region. And this is non-rejection region. Now, if you look at the test statistics 0.69, 0.369, this actually is located here. So now this time, the test statistics fall in the non-rejection region because T-score is 0.369. So this means that test statistics falls into non-rejection region. That means that builds ground for the final conclusion. So fail to reject HO. Another way of saying fail to reject HO is true, accepting HO. But typically we do not say accept HO because remember we only have 95% confidence here from the question. So it's not 100% confidence, That's why you can never say it's 100% confidence, accepting HO, or HO is always 100% going to be true. And that just doesn't, it doesn't happen that way. So we just using this language carefully. We say fail to reject HO, indicating that HO is true with 95% confidence. Okay. So that being said, since HO is true, that means average grade of population is less or equal to 80. Okay. So based on this intrinsic conclusion, we know that average grade of the population is less than or equal to 80. Okay, with 95% confidence. You want to just put in that 95% confidence. So that will actually give us an idea why we say fail to reject instead of saying accepting HO or HO is 100% true, right? That's not exactly the case. So that's why I pick the language carefully just to make sure, we do not overstating the outcome. Okay. So, any question about this? And as I mentioned, the z-test, right? The p-value method could only be used for the z-test, meaning with the normal distribution, we use the p-values available. I'm going to show you how to use a p-value to make a decision, right? So think about this. So this is a rejection, non-rejection method. So one more time, let's take a look at the very first question. I'm going to show you p-value method for that one. You will see we reach the same conclusion. The only thing is p-value method is just using probability. Yeah, so let's go back here. All right, so question one, right? One more time. I'm using p-value method this time to do this. Compared to the rejection, non-rejection method. Okay. So p-value method. P-value indicates probability. So you are calculating probability to determine outcome and compare the probability to alpha. Probability. Now one more time, question one, we could just go back. So step one, we already know that we state the null, HO, and H1, right? No and alternate hypothesis. The higher than that, okay, so the average, so H1 is greater than $1,800. And then double check which one they are using for, yeah, less equal to, right? So but null hypothesis is a complement, so mu is less equal to $1,800. Okay. And we know that based on H1, we know it's right tail test. Okay. So step one. Step two, calculated test statistics, right? So using ZScore. X bar minus population mean mu over population standard deviation over square root sample size. So sample mean is here 1950. Sample mean 1950. And we have 40 claims, so meaning sample size is 40. Okay. Population standard deviation sigma is 500, alpha is 0.05. And right, so we have all of that. And population mean mu is 1,800 based on this null hypothesis. So now we have all the numbers we need. Sample mean 1950, population mean 1,800, population standard deviation is 500, and sample size is 40. Double check, yeah, 40. Okay. Now we have all these numbers. Throw into the formula one more time. Okay, 500 over square root of 40. So now this is ZScore, so we run it to 2 decimal place. But then let me just put into the Excel, get the result first. 1950 minus 1,800 divided by 500 standard deviation over square root of 40. Okay. Proper input, he enter, get a result. 2 decimal place, 1.90, right? We did it already, it should be the same. So 1.90. So now instead of using, so this is our test statistics. Now we're talking about right tail here. So test statistics Z-score is 1.90. So the p-value method is try to find out the probability according to this Z-score on the right tail. So now let's go to the table A2. Since Z-score is 1.90, we'll be able to find the area to the left. 1.90 give us probability to the left. It's 0.9713. You can easily locate it in table A2, 0.9713. So that means area to the left is 0.9713. And now area to the right will be 1 minus 0.9713. So this turned out to be 0.0287. Now we compare this to alpha. Alpha is like the minimum probability you need to surpass in order to make sure this event is occurring. Meaning with such a low probability, right? So this is 2.87% of chance this will occur. This is very low probability. It's lower than 5%. Lower than alpha. Alpha is 5%. 5% is already very low. However, 2.87% is even lower than that. So we call this highly unlikely event, right? So that means it's not happening, right? With realistic estimate, it's not happening. So since p-value probability is 0.0287 less than alpha, okay, that means it's highly unlikely event. Since it's highly unlikely, reject HO, right? It's not going to happen. It's not going to happen. So we reject it. So the conclusion is reject HO based on the p-value. Since the p-value is extremely small, it's even smaller than alpha, reject HO. So the conclusion is, so the fourth step, reject HO, meaning HO is probably not true. So that being said, H1 must be the true statement with 95% confidence, which is the population average mean will be higher than 1800. Okay, so in this case, the true average claim amount is greater than $1,800. So management should be concerned, right? So we reach the same conclusion as the other method I just showed you earlier. You can go back to that really quickly. About the very beginning, we tested using so the actual mean is higher than 1800, right? Because test statistics is forced into rejection region, reject HO. So both methods yield same outcome. And still, since the actual mean is higher than $1,800, then the company could potentially lose a lot of money. So they should modify the policy rate to avoid it. Okay. So the p-value method, give us same outcome, right? Same result, no difference. Totally up to you. But the p-value method only applies to the z-table, right? Only if you can use z-table, z-test, then p-value method works. For the t-test, p-value method does not work. Let me show you why. Because for table A3 only gives us the critical values. There's no p-value provided here. So that's why p-value method is only applicable to the z-test, not a t-test. So that's why rejection region, non-rejection region method, that works for both categories, either z-test or t-test. Both tests are applicable here using the rejection, non-rejection region. Okay. All right, so that's basically everything I want to talk about in terms of the hypothesis testing. And we still have like about 10 minutes. So if you have any question about the project or anything like, and I think a lot of you guys get confused about the project number 5. There are 2 questions here. Most of you guys did a good job on the first question, but you probably most of you guys forget to complete the second question. There are 2 questions here. Let me open that really quickly so you can still work on it, right? Complete the question number 2 and submit it after that. I will still take a submission. Okay, so let's go to the file. Yeah, here we go. So this is Excel project number 5. I had 2 questions, Q1 and Q2, right? A lot of you guys did a perfect job on Q1, but you skipped the Q2. So I usually write a little feedbacks in your Excel submission, so you can just make up the question 2. Very similar, right, to question 1. And submit it again. I will, if you want to improve the score, right? But yeah, feel free to talk to me. I can put you in a breakout room if you want to talk to me about any project for like maybe another 10 minutes. Okay.
So you said there's. Oh.
Yeah. Hey, Nigora.
Yes, you said there's a second question to project 5.
Yes, exactly. That's what I try to explain to you. See, that's a Q1 and Q2. So that 2 here, right? So you probably didn't notice that. So you can make up the question 2 and submit it again.
Oh, when I downloaded it, there's no question 2.
Oh, okay. For some reason, maybe you sure? Because this is the file I attached. Maybe I don't know. Maybe something happened on the Excel program. You know, it wasn't.
Maybe.
Yeah. Can you see if you can reopen it, and then see if you can find a question 2 underneath it?
Okay, yeah, found it.
All right. And don't worry, you can make it up and submit it again.
Okay. Are you able to meet on Wednesday again?
Yes, 9:30 a.m. Okay.
Okay, sounds good. Thank you.
Great. No problem.
Bye.
Okay, bye. Hey, Felicia.
Hi, I was just confused about the Excel project that not from not the recent one, but the one I submitted. Because I thought I was just following like the formula that we did that day, and I thought I was doing it right, but I guess I wasn't. So I'm just confused about like what I was doing wrong.
Okay, let's take a look at your submission then. All right, and then go to your account. Okay, let's see. Three, 4. All right, I see why. Okay, I'm gonna open the file. I'm gonna share the screen with you.
Okay.
Yep. Okay, so this is your submission. Okay. Yeah, that's yours. Okay. Here you go. Yeah, so first of all, let me see. And this is totally off, right? B0, B1. Let me show you why this is off. So for some reason, okay, the number is off. Okay, so let's see. So those are the 6 numbers. Okay, so you need to sum up that. There are 2, 4, 6, 8 numbers, right? And
yep.
You need to sum up each one of these. So total here. Remember, you got to do the total for all these different values.
Right.
Right. So you're going to use these numbers to calculate the B0, B1. Right.
Oh, okay. So I was just not doing the total by accident.
Yeah, you didn't do the total. So that's one thing. Also, let me show you something really quickly. You ought to double check your result, right? You can click on trend line here. Click on plus sign, see trend line here. Click on more options. And display equation, display R squared. That will give you guidelines whether or not your B0, B1 is right? Because Excel gives you the accurate result. So when you calculate B0, B1, it's totally off from that. That means your outcome is off. So go back, double check the numbers. That's why I show you this last time, just to give you guidance, so you do not, if you made a mistake, you know how to correct it. So definitely, right, sum up this, each one of these, get a total, calculate B0, B1. And once you have B0, B1, then you have the regression model. Then replace X with a 9 to get a predicted Y values. And also replace X with 25 to get a predicted Y values. So you have, after that, after you have regression model, you still need to estimate the Y values.
Right, okay.
Yeah, also for the correlation coefficient R, again, you're gonna use the formula, right? With the proper numbers, right? Pretty sure you'll be able to figure out this. And then R squared, just square the R. Okay, you get that. And here you should write a summary statement saying that, let's say R squared is 81.1%, 81.1% of the variation explained by the X values. At least you should state that, right? That's a
Wait, what was that? Say again? I'm not.
So you see, the question is asking what percentage of the variation is explained by the X values. And when you calculate R squared, and say percentage, you need to state it in a sentence, saying that, let's say 81.1% of the variation is explained by the X values. That's a conclusion. Yeah.
Got it.
So that, so if you modify that, you'll be able to get a full credit for question 1, right?
Okay, thank you. I appreciate it.
No problem. For question 2, very similar, right? Just follow procedure, get X, get B0, B1, all of this, and identical. Yeah. Okay. So you can revise on it and then fix it as you want and resubmit it. Okay.
Okay, thanks.
All right, no problem. Hey, Neil.
Hi, Professor.
Any question?
Would you be able to meet with me Wednesday morning?
Yes, 10 a.m.
Okay, great. Thank you so much.
No problem. All right, guys. So we will review next Monday, right? And then next Wednesday, you're taking a final. And I guess I'll talk to you guys next Monday. Bye-bye.
Thank you.
Bye.